So we've been asked to create formulas for H and G and use them to predict salary at 4 years. Well, I'm going to look at G first because we earlier found that that was a line. Each time we were going up by 17, where 17 represented thousands of dollars. So I could say normally y equals mx plus b. M is my slope, and b is my y-intercept or my starting value. So I can see that starting value at time 0, 0 years, that's going to be $10,000. And my slope was up 17,000 per year. So that leads me to y equals g of t equals $17,000 times t plus $10,000. Now for h looks like more of an exponential function, and it looks like 10 to 15, well, that was times, as I was saying, we're looking at an exponential function. And so each time, you should be able to multiply the value before it to get the next value. So we could look at 10 and 15 and say 15 divided by 10 equals 1.5. What is 22.5 divided by 15? That's also 1.5. And so this exponential formula would be in the form of y equals h of t equals some starting value a times b, some multiplying ratio each time to the x, or in our case, to the t. And so our starting value is obviously this 10,000. So we would say 10,000 times each time we multiply by 1.5 to the t. To check ourselves, we should try some values. When I tried 3 years, we would have 10,000 times 1.5 raised to the third power, and we would get 33,750, which matches this y value of 33.75 in thousands, in 10,000 per year. So then you were asked to predict the salaries at 4 years for G and H. So G of 4 would just be plugging T in for 4 in for T, and we'd have 17,000 times 4 plus 10,000 for a total of $78,000. And when we plug in 4 to H, we have H of 4 equals $50,625. Using units, interpret your answer to number 5 in the context of the problem. Well, this just means the salary in dollars after 4 years of work.